In this video we want to talk about the concepts of reliability and validity. Now we mostly encounter this in statistical theory and in particular in looking at sampling how it's conducted from population and the reliability and the validity of the statistics we get from that sampling process. But it's got wider applications in business as well. In this video we want to just run across the meanings of the words and how they are interpreted and used within the framework of mainly statistics, as I said. So research is reliant on data. Now this can be raw data or from secondary sources. In other words, it can be primary or secondary. Primary data is data that's found for the purpose itself. The data is original to that particular project. It's researched from the source. Whereas from secondary sources, these could be government publications, for example, the data is published, it's collected by the government, let's say, and it's published, and the researcher picks up the data from there and then goes along to subsequently analyze it using some particular statistical techniques or some tools of analysis. So we have data from two sources, primary and secondary. Information is vital for research and effective decision making. Information is different from data. Information is, if you like, processed data. Information is useful. Data is just unprocessed. It doesn't have an informative content. It may be just numbers, facts, figures. But when they're analyzed and processed, they become information, they become useful. So information is vital. It's very important for the business community to have access to good information, reliable information, and this will enable them to make effective decisions. So good information is important in business. But good information may start by looking at data, going to some source of data, primary, going directly to customers, for example, and asking customers' opinions, or it could be going to secondary sources of data, perhaps surveys that have been produced by other companies or other agencies, or databases which are being sold, or whatever it is. That would be secondary sources. But whatever the source of the data, once it's processed, it becomes information, and that's good for effective decision making. The problem is the information reliable? Is the information good? Information needs to be assessed in terms of its reliability and validity. So we have two tests for information to see if it is good information. If it's not good information, clearly it shouldn't be used. Reliability and validity determine the success and accuracy of research. But they also determine the success and accuracy of decision making within business. If a business makes a decision based on some information it has, but that information is subsequently shown to be faulty, then of course the decision was faulty. But we have the use of reliability and validity within research as well to see if the research findings are useful. So it may be that the research findings are not going to be applied within business. They might be just perhaps indicating trends in the market or changes in the industrial structure of a particular society or whatever it is. Then the in that case, the outcome would be unreliable if the validity and reliability criteria were not met. But of course, for a company that's going to make decisions based on information, the information should be good. So let's start by looking at what we mean by reliability. Information must be reliable to determine its accuracy. Reliability is research that is error-free and consistent. So information must be reliable to determine its accuracy. Information must be reliable. If it's not reliable, it shouldn't be used. If it's suspect, then it shouldn't be used. Reliability is research that is error-free and consistent. So if it is error-free and consistent, it's reliable. If research is repeated over a number of times, to be reliable, the research will produce the same results in repeated trials. So if the same test is performed over and over, the same outcome should emerge. In that case, it's reliable. It's producing the same result every time. The idea behind reliability is to assess the research its suitability, regardless of sample size. So the idea is to make sure that the information that's taken from the data is reliable. And if the data is processed over and over, it should yield the same recommendations, in which case we would say it's reliable. Will the research produce the same results to a wider population or geographic location? Now this determines reliability. If, for example, a researcher selects 100 consumers and asks their opinion about a certain product, say 100, and let's say the researcher selects these randomly and there's no bias in the sampling method, then depending on the results of that particular piece of research, is it then fair to say that the statistics that have been calculated based on that 100 sample, that these could apply to the whole population, perhaps a population of many thousands? If the sampling method was unbiased and if it was conducted properly, we would say it is reliable, and therefore we could apply it to the wider population. Reliability can be assessed in regards to primary research, as the research is relevant and produced for the purpose for which the research questions. So we normally associate reliability in this case with primary research because the primary research is conducted in-house. It's done under these rigorous constraints that the sample must be selected randomly. There's no bias in the questions. It's done so as to be a clean exercise, and the information coming back from the sample is therefore reliable. It could be the case that sample data produced and published elsewhere and is then subsequently used by organizations as sources of secondary data, that information could be biased. Perhaps the agency conducting the sample were not as diligent as they should have been. Secondary research can be unreliable if it is from secondary sources and not specific to the research question. And that often happens in research, that the researcher finds some data, but it's not directly linked to the hypothesis under examination, but it's peripheral. It's in the same area. And there's a feeling by the researcher that if this information is processed, it could shed light on different part of the research. But that data was collected for a different purpose, and therefore perhaps will detract from the reliability of the research, not add to it. So secondary sources are more unreliable than primary resources. Primary resources can be controlled. Now validity. Well, validity answers the question, is the research measuring what it's supposed to measure? It's a straightforward question. Is the research measuring what it's supposed to measure? Or is it measuring something else? Sometimes researchers, particularly junior researchers, may undertake some research. It's somewhat peripheral to the main question, but they are assuming that it is germane, it is pertinent, and they will put it forward as a solution or as an insight into the main question. Validity is an important factor in research. Our research is unsuccessful if it does not address the main purpose of the research. So the question that the research is looking into must coincide with the question under investigation. It's easy for researchers just to be sidetracked, just to be pulled slightly to one side, and therefore they're getting an insight into something, but it's not the question that they're supposed to be investigating. And that would cast doubts on the validity of their research. Validity identifies the extent to which information collected is intended for its use. And that's often a problem in business. Information collected for one particular use is then used for something else. And that may not be valid. It means that the applicability of that data and that information in the case in which it's used may invalidate the whole research. So it's important that there is an alignment between the question that needs to be answered and the questions that are posed in the research. This should accord, they should line up. The questions asked in the research should be relevant to the question under examination. If it is, then it would be valid. In order to ensure research is valid, it must be assessed in line with research objectives. So it's important to look at the research objectives and then try to align the research objectives with the questions that are asked in the research activity, so that the two are lined up. Research can be reliable but not valid. On the other hand, if research is valid, it can be reliable. But if research is not reliable, then it cannot be valid. That may seem like a party statement, difficult to untangle. But research can be reliable but not valid. It's a situation where the research must not just ask questions that are relevant, but it must also use techniques that are likely to give the best and most reasonable insight into the phenomena under examination. So the techniques that are used, which determine the reliability, these can be well established. So it could be a well prepared piece of research, but it's not asking the right question. In other words, it's reliable, but it's not valid. So the research is well performed, the sample is well drawn, and the questions are clear, but the questions are not the questions that are meant to be asked. The questions are tangential to what needs to be asked. If research is valid, it can be reliable. Sometimes if the questions that are being asked directly relate to the question that needs to be addressed, then that will pull the techniques, the research techniques, into line. So it could be the case that a valid inquiry will lead to a reliable one which could produce the same results if performed over and over. But if the research is not reliable, it cannot be valid. So if it's not reliable, in other words, if it's biased, or if it's asking the wrong questions in the sense that it's posing its techniques based on questions that should not be posed, so it's biasing its own work. If it's perhaps introduced bias in terms of the sample selection or the questioning of the respondents, then it's not reliable. So it doesn't matter what the results are, they are not valid. They're giving an insight into the question, but it's not the question that has been posed. It's the one that the biased sampling technique has thrown up. Reliability and validity are both important components in assessing research. Both need to be completed. And just to summarize where we've got to with this, it does sound complicated, but reliability means that the results could be repeated over and over. If the technique is good and there's no bias and the questions are clear, straightforward, and this sample is selected so there's no bias in the sampling, and so if it's reliable, then it's likely that if we perform the same question over and over and over, we would get the same set of results. So if we perform the same research, I should say, over and over and over, we get the same set of results. And the results for that sample could be extrapolated into the wider population. So if we have a sample of 100, we get a certain result. We could say it applies to that particular population, providing, of course, the sample and the population have the same attributes. Validity means that we're asking the right question. It means that the whole exercise is focused on the question that needs to be answered, and that therefore the research is not being sidetracked into giving insights into other areas, or it is focused. That's the point. So reliability and validity are both important components in assessing research. It's worth going over this a couple of times and making sure you're clear with what's meant by reliability and validity. They are quite straightforward concepts, but they are unfortunately associated with some of the more technical uses in statistics. the selection of samples and the use of sampling techniques, the reliability of sampling techniques, and the validity of the whole exercise, whether it's asking the right questions or not. But that's all we're going to deal with in this video, so let's leave it at that and say thank you for watching.